Example of DFA, in which I have 5 states: A, B, C, and D, and E. So, are thus to minimize the DFA, and I want to design another DFA which performs the same kind of task, but I want to use the minimum number of states possibly. So here is the 5 states: A, B, C, D, and the last is D. The first step is to draw the state transition table. A is the initial state of the starting state, and E is the final state, and we're getting inputs to 0 and 1, so where the states go to. Write down the zero equivalence. In order to write down the zero equivalence, it's very simple. You have to just write the non-final states together as one set, and you have to write the final state as another set. So here what are my known final states: A, B, C, and D. So I will make this as one set, so it's very easy to write the zero equivalence. Just write the non-final state as one set and the final states as another set. Bring down the A, or the initial state. Let's come now to one equivalence. Writing one equivalence, you have to look this row of zero equivalence, and you see that these 4 states are in one set. Now you have to check if these states are one equivalent to each other. For checking A and B, you have to check in the transition table. Where does A and B go to in getting input 0 and 1? And if you see that the states to which A and B goes on getting particular input 0 and 1, if they fall in the same set, if those states fall in the same set as these in the zero equivalence row, then they are said to be one equivalent to each other. Alright, they may seem a little difficult to understand, but it will become easy to understand. So I am going to check if E and B are one equivalent to each other. A and B, where does it go in getting input 0 and 1? So A and B. So let's put this in this side. A and B, where does it go in input 0 and 1? A on getting input of 0 is go to B, and B on getting input of 0 is go to B. Then if they are in the same state, then let us go to input 1 because they are in equivalent. A on getting input of 1 is go to C, and B getting input of 1 is go to D. So now let's come now from the zero equivalence. If C and D are not in the same state or not in the same table. Now let's come now to one equivalence. We make another state or another set. Let's bring down A and B because it is in the same set. So we check C, D to A or B because these sets are already equivalent. So let me check A and C. Let's put in this side the A and C. A and C, when getting the inputs of 0, is B. So A and C are in the same set. So A and C, when getting the input of 1, is C. So they are also in the same set. So the result is they are in the same set also. Put C to one equivalence because they are in the same set. And after that, let's check if CD is in the same set. CD, when getting the input of 0, is B. And also, CD, when getting the input of 0, is B. CD, when getting the input of 1, is C. When CD, with getting the inputs of 1, is E. So, they are not in the same set. So the result is this not. So let's close the first set and make another set for the D and close, and make another set for E, or the initial state of our DFA. Let's continue to the two equivalence, which is we make another set of states. First, check A and B. A and B, when getting inputs of 0 is B, so there's no problem. So A and B, when getting the input of 1 is CD. Now check if CD belongs in the same set or not. So as you can see, C and D are not in the same set. So A and B, let's put A, or make another set for A, and let's put in another set for B. So let's continue. A and B are not equivalent to each other. So let's go to see if they are equivalent. So A and C, when getting the inputs of 0 is B, so there is no problem. So A and C, when getting the input of 1 is C, so the result is they are in the same set, and they are also there's no also problem. So close the first set of A. Okay, let's make another set for B and D, and also for E, because D and E, we do not have to check D and E anymore because they are in the separate set. They cannot combine in another set anymore. So let's come now to three equivalence. Okay, let's check if A and C, A and C are in the same state. So A and C combining a single state, and A and C, when getting the input of 0 is B, they are the same. So A and C, when getting the input of 1 is also same. So there is no problem. So it is called as a combining as a single state. Then so put it in A and C to three equivalence, bring down B, D, and E, the initial state. Let me draw the state transition. So A and C combine as single state. Or the initial state. B, another state. D, another state also. And the last was E is the initial state. A and C go to B. We're going to input 0. A and C, when getting the input of 1, we are going to C. So we are going to reverse A and C and input 1. Let's come now to B. When B is getting the input of 0, it's going to reverse also and input it 0. Then B is going to D input 1. D, on getting input of 0, is go to B. So we put 0. In D, when getting the input of 1 is go to E. So we input the 1. And E is getting input of 0 to B. Oh, we need to input 0 and B. Then E, when getting input 1, is go to C. So we need to input 1 to C. So